Is that better?
Does that work? Does that work? Yeah. Oh, yeah. Oh, yeah. Please don't feel bad.
To find the volume for the speakers.
Working on it. Try that. No, that's worse. Hello. I don't think the mic's doing the thing we want to do. Probably because I have another microphone that's picking me up. On the speaker off on one laptop and unmute on the other. It should be good now. Oh. I'm muted. Test. Should be good. Yeah. Oh. We don't need speaker. Let's get the speaker out. We don't need speaker. Yeah, it should be good. It should be good. Come on. In theory. Well, not the way things work around here. Maybe. That was the right thing. No. Just. Yeah, we just need to get the speaker off.
That's my document.
You want to mute her? Testing.
It's too close. Might be an off switch.
If she's using that mic, you may have to turn on.
Well, if I knew how to do that.
It would be under. Expanding.
Oh, that's, yeah, that's awesome.
Getting a lot of feedback.
Yeah, we know. You gotta see it from our side. Doesn't want to turn it off.
All those little knobs on the bottom side there, do they do anything? Keep going, keep going. See them?
Does this work now?
Yeah.
It's not going.
It's open from the other
Those are all
side.
jacks.
They're all jacks.
So I can just talk through that if that's okay instead of this, and I just won't leave the podium.
Yeah.
Or I think it's that mic in this.
Do not
mic.
disassemble that. I don't have authorization
One
to
of these
disassemble
mic.
that. You don't either.
Yeah, I'm taking this off.
Okay.
Why don't you just make sure that you can hear me through Zoom, based on the.
This one,
the
mic
current
over
layout?
that.
Yeah, use this.
Like, there's a mute video, actually.
Okay, I think we have it figured out.
I mean,
So we're gonna try this.
That does that. That disconnects that, turns off. the video.
All right. Should've stopped it. Maybe.
You can hear us there. You can hear us out there. Sorry for the technical difficulties. Welcome once again. Make some meeting announcements. Got the ASME South Texas section is meeting tomorrow at the Forest Club for the annual awards, honors and awards dinner. On the 11th of May, we've got the Apollo section has compressor re-rates and upgrades, machine test stand and balancing, as well as having their officer elections. On the 16th of May, we've got a Clayton Finney from Baker Hughes. Not exactly sure what the title is. We've had to do some adjustment of our schedule and our speakers. A little bit of, well, doesn't matter. Both Apollo and Gas Turbine Technical Chapter will have a planning meeting scheduled in May. We'll also have our year-end handover at the end of June. And there's a joint ASME, IAA, IEEE, and Enclosure meeting. IEEE is hosting it. That'll be sometime in July. Look for that announcement coming to an ASME site near you.
Is Gas Turbine and Apollo combining or?
No, but we do an awful lot of things together. We share officers, we share facilities. We share meetings on occasion. These are not necessarily specifically going to have the meetings at the exact same time because they don't, right now, the officer meetings aren't really, don't have a date specifically other than they'll both be in May.
Long time ago, they were one. I was just asking.
Yeah, no, we're not planning on joining them back together and at any time soon. Primarily because the Apollo is dealing with more than just turbines. So they're looking more at various types of rotational equipment, reciprocating equipment, compressors and whatnot. Okay, and sort of as a, I'm not in the right mode. I'm not presenting, so, but we'll live. At 5. Sort of as our diversity and inclusion moment, if you will. Want to remind the membership to celebrate individuals that have made a difference. ASME does have a lot of honors and awards to recognize your various peers, and probably one, although I didn't include the slide, this one happens to hit a note near and dear to my heart. I was the Design Engineering Division Honors and Awards Chair for 6 years. I'm also sitting on the Ralph Coates Rowe Award Committee. And we're always trying to find good people to, within the profession, within the society, to honor for the various things that they do. So it takes people from the membership to start the process. So with that, we're about ready. I'm ready to stop sharing me, and we are ready to start sharing our speaker. Which, while she's preparing things, I'll go ahead and do a brief introduction. Our speaker today is Collen Turley. She's a senior applications engineer for Solar Turbines. Colleen's solar journey began in construction services balance of plant department, where she supported the design of the first article patented Modular Solutions product. Post-product development, she's transitioned her balance of plant product knowledge to a business development role, becoming a proposal manager supporting balance of plant and modular solutions inquiries. Last year, she transitioned in her role where she is responsible for equipment selection and proposal development. She has a bachelor's and a master's in engineering from Stevens Institute of Technology in New York, and she loves teaching spin classes. I'd like to welcome Colleen Turley. Thank you very much.
Thank you.
Sorry, guys, with a little delay, but I think we're moving on. I'll skip my bio since we already got that introduction, but welcome. Like, just introduce, my name is Colleen Turley. I work for Solar Turbines. You'll see that heading a few times in this presentation, I promise. Today, we're going to talk about a simple approach to standardization. With standardization, we have modularization and optimization, a lot of buzzwords, but I'll be sure to clarify what that all actually means. So we'll be talking a little bit about gas turbines and about balance of plant. All right. Like we just said, I'm an applications engineer from Solar Turbines. What does that mean? Well, a customer comes to us. I'm going to try to stick over here. I apologize, the podium's in the way. I talk with my hands. I'm from New York, New Jersey area, so very animated, I promise. So what does an applications engineer do? We spec out equipment. We basically make sure our equipment selections are prominent for the provided range for our customers. So, right, like you want a horsepower range in your car, we provide that for gas turbines. All right, so we take the exact exact turbine selection, gas turbines, compressors, and a variety of other products, which I'll get to shortly. Like you said, I have a bachelor's and master's in engineering, but I think I talked to most of you tonight. My career started out in a different sector than it's ended up. So just a little of advice to our students in the crowd. You never really know what turn an industry will take you. I love my job now. I work for Solar Turbines, like I said. Our vision is really customer focused. So you'll notice again and again, I'll explain this global footprint that we have. We really aim to be in our customer's backyard. So what does that mean? We really try to eliminate the headache of purchasing a turbo machinery product, implementing it, commissioning it, and then the full lifespan of the product all together. So, right, our vision is that you come, you purchase, and the equipment starts running seamlessly. So how do we do that? And how do we do it in a simple way that's standard, small footprint, and ease and accessibility? Well, before we get there, so Solar Turbines, its name alludes to, I get a lot of inquiries that, do you provide solar panels? Do you provide wind turbines? And I laugh every time I open up a LinkedIn request thinking that I provide such things. But no, Solar Turbines, we're a gas turbine company. We're in 100 different locations worldwide. We're owned by Caterpillar, a subsidy since 1980. And you can notice at the bottom, right? I keep harping on our global workforce. So we're a global company in many different touch points around the world. I'll start painting that for you just because it's important to see how many different applications, how many different products our standard and modular products are implemented. All right. So like I just made the joke about solar panel company. Solar was founded in 1927. I won't harp on this too long, but it is interesting to see how we've developed as a company. So we started off manufacturing small airplanes back in, like I said, the 1920s, moved on in the 1950s to gas turbines. And since then, we've started to refine and improved our offerings And now we offer many different product lines, which I'll get to. But we've been in the sector for over 50 years, have a very robust product. And over the course of our span, we've implemented and adjust to our customers' needs, right? So I'll talk a little bit about our insight monitoring and how we shift gears in order to implement our customers' needs. All right. So as I explained before, our headquarters are in San Diego, the lovely sunny location of San Diego. Yes, I know I'm lucky when I get to go visit San Diego. I love it every time. It's beautiful. We have two facilities, one in Harbor Drive, the other in Kearney Mesa. Harbor Drive, if you've ever flown in, is right along the waterfront, right near the airport. That's really where our corporate office is, as well as our component manufacturing, our R&D facilities, a smaller office compared to our Kearney Mesa facility, which is located inland. And our Kearney Mesa facility is where we final test and assemble all of our products. So we're proud to say that we manufacture and assemble in the USA. Okay. I'm going to slow down and take a deeper look at our field offices. Before I get to our product lines and how we standardize and make our products into a really modularized product, which therefore is optimized, I'm going to talk a little bit about our field products. So as I explained, we have a global footprint. We have many different offices across the globe. From the Czech Republic to Mexico to DeSoto. And these are just a few that I've selected in order to really show that global footprint. And so with that global footprint and our customers purchasing our products, we have manufacturing and field offices right in their backyard. So right, like I said before, being close and being in our customers' backyard reduces our logistics time and therefore improves our response time to them. So as many of you can probably relate to, this really helped us during the pandemic, as well as other world crises, because we have employed local nationals, we have all these field offices, all these local service personnel that know the language, know the culture, and really can help us be successful in those field applications. All right, so I realize there's no key. I realize there's no key on this map. And that is really just to show the dots on the map are really just to show a picture of where solar has offices, field offices, and manufacturing facilities. So like I've explained before, we are a global company and really where our products go, we go. So this is really this slide is really meant for a lot of the students in this room. So like I explained, solar turbines, what does that actually mean? We manufacture gas turbines. So where do you put gas turbines in? What applications? So solar turbines mainly focuses on, and granted not limited to, we have a variety of different sectors we're involved in, but mainly in oil and gas and upstream and exploration, midstream, which is transmission of natural gas, pipelines, processing, and then we also have a sector of industrial power generation. And I'll explain a little bit more about that. You can see the pictures in there. We can dive a little bit deeper, but basically generating energy, compressing gas. And here are our major customers, not limited, but just some of our customers to start to show our footprint in the upstream, midstream, and power generation market. All right, so I'm sure many of you have recognized some of these names. Like I said, just to start painting a picture for where and how we implement our products. All right. Take a moment for you guys to take a look at our gas turbine family. Welcome. They're beautiful. They're my bread and butter. We have a few different gas turbine engines. Like I said, This is not the only thing that Solar manufactures. I'll get how the gas turbine's paired and how it's packaged in the next slide. Our gas turbine family ranges from our Saturn 20 engine, which is about 1,600 horsepower, all the way up to our Titan 250, which is about 32,000 horsepower. Solar continues to invest in these power ranges and continues to invest R&D to meet our customers' needs. So we're constantly refining and revisiting how we approach our design and quality of these products. So if you take a look from a mechanical engineer's point of view, these all look pretty similar, right? So how does Solar do this? How do we have all these different product lines, right? We refine and we say that we have similar components. We start to standardize. Our R&D facility leverages aerodynamic and combustion principles from some of our engines and some of our components to scale them up and down, right? Just as if you've had a part that continuously works, you can use those same similar principles, scale up and down for improved quality, reliability, and familiarity around our customers. All right. So also, as I start to paint the picture of these standard systems, right? These engines with subcomponents, major components, minor components, whatever you want to call them, they all contain sub-assemblies, right? You have a fuel gas assembly. Every engine needs fuel. Same thing. Our sub-assemblies are scaled, leveraged across our whole product line, and used consistently from product to product. Okay. So now it's starting to get interesting, right? You know who Solar Turbines is. You know, we manufacture gas turbines. What does that actually mean? What does it connect to? So Solar has complete package systems from compressor sets. We're well known in our compressor set type field, as well as mechanical drives. So, right, a mechanical drive such as a pump or a generator set on the back end, a gas turbine feeding a generator set. We also have an electrification product we call our Spartan EMD, electric motor drive. We also have an SMT product, which is our solar mobile turbo machinery. And this allows us to bring our gas turbines on the road. You'll see a picture of that shortly. It's basically a mobile version. All right, so like I said, we have a Saturn 20 all the way through a Titan 250 paired with either a compressor set, generator set, or an EMD with a compressor set. What I'd like you to start noticing is the different standard, though these are all in gray, the standardization from even a base level, right? You look at a compressor set to a generator set to an EMD. They all look very similar, right? Besides the Solar logo. Solar really tries to standardize not only in the packaging, right? But we package it so that we can streamline the manufacturing end. And that'll become more important when I explain balance of plant and how we approach that. All right. So gas compressor testing. So like I said, I keep using this pre-engineered integrated solution. Since Solar leverages a lot of their components from product to product, everything is pre-engineered, pre-tested, and assembled before it leaves our door. So a lot of people in industry neglect to forego our the ASME PTC type 1 and type 2 test. And for those of us that aren't necessarily familiar with those codes and standards, it's basically a very time consuming and costing test at site. So by Solar Turbines, having their compressors and their turbines pre-tested at site, pre-tested in our facility, it allows us to streamline things on the construction and commissioning. It may not mean anything to you guys right now, but when you start putting a dollar to that, you know, if there's a certain monetary value that you're tracking per day, that really streamlines not only the risk at site from a safety point of view, but it also saves a lot of money. So before I move on to balance of plant and how that plays a role in all this, right? I went really high level on turbo machinery, what it is, how we implement it. We also have a variety of other facilities that we manufacture, and we have facilities in Texas and DeSoto and Maybank, as well as around the world. We actually have one here in our backyard in Houston. In Channelview, we have our construction facility called TurboFab. And then in Houston, we have our construction services team. So that's what I'm showing you on our screen. So construction services, I'm sure you guys can read the bullets on the slide, founded in 1968. Similar structure to our turbo machinery products in San Diego. We execute balance of plant designs in a project engineering and project management order, just like our turbo machinery. And we have a global footprint very similar. Okay. So the manufacturing facility. The manufacturing facility has a large footprint. Like I said, in Channelview over by Baytown, in case you guys are ever over in that area. We have a waterfront facility, which allows us to do barge loadout, which is pretty cool. You can see me in the bottom right-hand corner. That's probably one of my cool bragging moments next to a shackle that you offload something offshore. Like I said, we have a waterfront facility. And just to give you a scaling point of view, one of these yellow structures right here is about 500 short tons, 80 feet long by 60 feet high. So we have a pretty big manufacturing facility, if you think about it. And this allows us to manufacture all of our balance of plant and modular equipment, which I'll get to in a second. But just really wanted to start painting the stage for who we are in Houston as a modular and balance of plant point of view. That top left building is actually our paint facility. This not only paints spaces for our turbo machinery, but it also paints all of our equipment for Modular Solutions. So I keep throwing this term around balance of plant, right? If you haven't worked in the industry, you may not know what is it, right? It sounds like a piece of equipment. Well, it is. It's all the equipment surrounding our turbo machinery. So picture this big engine. Engine needs fuel, the engine needs seals, the engine needs their process gas treated, the engine needs a variety of things in order for it to run to compress gas. Well, the balance of plant equipment, believe it or not, it needs a lot of supporting equipment. And that's what I'm talking about when I say balance of plant. It's everything exterior to this black box that we call turbo machinery. So just like I said, turbo machinery is standardized from Solar. And that's the point of this presentation, right? Saving money, time, and risk by standardizing your process on your turbo machinery front, but also exterior to it, your balance of plant will create a better life cycle of your product, as well as more uptime. So I keep harping on modular solutions. You guys are probably wondering, what is it? What is this pieces of equipment external to the turbo machinery? What does it look like? We'll take a closer look. So these are standard engineered to order integrated systems external to our turbo machinery. So you notice over here, this layout is exterior to the turbo machinery, but it sits outside. Our open ground modular product, this product is for mild ambient conditions. It's our leanest and meanest approach. Still standard, still has pre-integrated systems, but I want you to start seeing this as building blocks, right? Pre-engineered subsections, Lego blocks that you connect together to create a full balance of plant system. We do so on the modular buildings and enclosure side, but creating this weather protected element by stacking blocks on top of one another. I'll show you a little bit more about what I mean by that. All right, So I mentioned open ground modular. So this is a type of product that we offer for exterior to the turbo machinery, right? It significantly reduces construction time. And why does it do that? We have all of our components pre-tested and integrated into these blocks and these subsystems. So the theory is that you drag and drop, you place down these Lego blocks and you interconnect the subsystems, right? It seems really elementary, but typically the way balance of plant is designed is everything is site specific, right? You size a vessel, you size a valve, you size a fuel gas skid, and you design it. Well, the way that we have designed these subsystems, let's take fuel gas or a utility module, for example. Our fuel gas is designed similar to our turbo machinery. You have a product range, you have a estimated operating range for estimated gas, estimated elements, and therefore, right, things may be over optimized, but you have it pre-skidded and pre-tested on a utility block that you place down at site. You interconnect from one end to another, no need to hydro test, and you're there. You can imagine from a construction point of view that saves a ton of time and hassle and risk.
Do all of these fit on a standard truck bed?
They do. Great question. Well, I'll dive into that a little bit at the end. So remind me when we get to questions and I'll address it a little bit more about our logistics. Thanks. All right, so moving on, I'm just going to make one more point before I get to our other product lines. So many of you may not know what an LER is, a local equipment room. So a local equipment room is our electrical building, right, to support all of our subsystems on site. This LER design is a standalone building, still has our same equipment, our MCCs, our switchgear, HVAC unit, whatever you want to put in your local equipment room. You'll notice this local equipment room again when we get to the building design, except it's integrated as part of the building. All right, so maybe I'll just chime on to our logistics question. So we have all these pre-integrated blocks, same subsystems as our open ground modular, same supporting turbo machinery products, except we have noise attenuated panels on here. So these are our Lego blocks, we call them. They're stacked, they're integrated, and they're connected to create a weather-tight structure around our turbo machinery. They are about 8.5 foot in height, so they're a legal permit load to put on the back of a flatbed. The theory is you drive up to site, you take a crane, and for a few days, you're offloading blocks and assembling them on site. So therefore, you have a safe space in order to finish assembling, and it's also weather tight. But they're normal permit loads for you to be able to transport them. It may seem like that might not be a big deal, but when you start paying for permits and you cross from state lines to state lines, those add up, as well as transit times. So these, a lot of them are legal loads, and if not, they are minor permits. All right, so taking a closer look at these subsystems that are integrated as part of these blocks. Again, you'll notice fuel gas and seal gas treatment, fire and gas detection, all this stuff, when stick built at site, is individually constructed. These blocks arrive from our building products as pre-integrated systems. They've done their point-to-point checks. You know, they electrically work. You know, if they have any pipe, they're hydro tested, and they're ready to go. You just bolt up some flange connections and you daisy chain some wires together and you're good to go. So why does that matter, right? Well, taking a look at a big building like this, right? Our configurable modular building, that's a mouthful, I know, but I'll get to the other product lines that stem off of this. When creating a larger building like this, we call this our Taj Mahal of products, our largest and biggest product with an overhead bridge crane. It saves time, it saves money for construction. Like I said, you assemble the Lego blocks and you have a weather-tight structure. So this is an example of one of my sites that I've actually worked at in Oklahoma, very near and dear to my heart. lots of days and heartache put into that one. But I want to give you my first case study, right? So I promised you case studies on this meeting invite. So take this for an example. One of our other customers ordered several different buildings in a different location of the US. Very different site conditions, right? All of us know that environmental conditions from one state versus another, even one side of Texas versus another, right? We got different weather all over the place. Well, the ability to have the same building and design, especially for a site like up in the Northwest corridor where you have high wind, high seismic, high snow, and having the ability to duplicate those sites from site to site, not only saves construction cost, but it standardizes things. So, right, the whole presentation has been wrapped around standardization and modularization. So if you have a field service personnel from your operations crew go from one site to another, you'll know where to find the fuel gas filter. You'll know where to find the tag you're looking for if a piece of equipment is down, and that is valuable. Similar operations manuals, you're streamlining knowledge from one person to another on the customer point of view, but also for us to help you as an OEM. All right, I won't bore you guys too much. Another product line that we have is our lean modular building. This is a smaller footprint. And this has you'll notice a very similar balance of plant layout exterior to the building. But another feature of this building is you actually have a large access door. Basically, you can bring in a truck and access the turbo machinery for overhaul and maintenance activity, right? You're like, okay, cool. This is a cool product, but why does this matter? These similar Lego blocks, as I call them, right? Still stacked, still integrated with those pre-engineered components and pre-tested, completely different building layout than our last product we showed. Different footprint, but same sub-assemblies, right? Which I said before, leads to streamlining through our field service personnel, as well as our customers. So everyone knows how things work together, how things connect, as well as helping for commissioning and right if you have any troubleshooting that you need to do. All right, so moving on to our enclosures. This is the last product line, I promise. I'll get to the full 180 of this all, right? Why does it all matter? We're all wondering. Okay, well, before we get there, our configurable modular enclosure, same footprint as our lean modular building. It has an integrated local equipment room as part of it, right? It's an unclassified part of the building. Similar LER to what you saw in the open ground modular product. So again, drag and drop these individual components, integrate them in a different product line, and you have a whole new product. Okay. So total life cycle support. So why does all of this matter, right? You have all these different products, you have standard equipment that you're selecting, it's all put on a skid or integrated into a block. Well, it matters over the total life cycle of the product. So from a customer's point of view, their operations personnel knows how to troubleshoot something, knows where to find something, knows even where the operations manual of something is, right? Something small and meticulous like that. It also allows us as Solar to provide technical training across a fleet, right? You could take an operations and maintenance principle class for one engine and similar principles apply to another. We have certified service parts. So also leveraging spare parts across from site to site, which could cause tens of thousands of dollars, right? This total life cycle of the product is saved because you have standard components that are found in the same modularized fashion from product line to product line. Told you guys I talk with my hands. Sorry about that. And then you're optimizing over the total life cycle of the product. So one thing I'm alluded to earlier in the presentation, when we were going through Solar's history, who we are as a company, what we offer, is our Insight platform, okay? So what does that actually mean? So value for the entire life cycle. We offer a machine to cloud-based ecosystem that allows us to monitor the healthcare of our turbo machinery. Okay, that's a lot of words. What does that actually mean? It's basically a data-driven system that takes data from our turbo machinery, sends it back to us for us to monitor. You're like, okay, cool. What does that actually do? Let's take a closer look at it. All right. So taking a look at this balance of plant layout, right? Very similar to ones that I've shown you before. Our standard turbo machinery in the yellow comes with Turbotronic 5. That's our standard control system. That is how our turbo machinery talks back to either customers' controls or our own internal master controls called Station Edge, Station Edge. Highlighted in yellow is our Station Edge, which is our compression management system that basically integrates your balance of plant network into one manageable system where it's reported back to our Insight platform. And that's where we monitor this data and provide an equipment health assessment. All right, so that's cool, but that doesn't actually mean anything to many people in this room. So everyone, I'm sure everyone's familiar with these fitness bands. I have a regular watch on, but I see many of you have a fitness watch, an Apple Watch, Fitbit, a Whoop, whatever you want to name your fitness watch. So, right, like a fitness watch, you have data that you're collecting, right? From either steps to exercise calories, let's call it that, to sleep, right? We're all worried about different things. We're all collecting this data, right? Sending it back to a central system, maybe called Apple, and they're reporting back and saying, hey, you know, last night your sleep was not great. It was only 4 hours. And then you take that back and you go, so what happened last night? What did I do differently in order to operate like that? From our Insight platform, very similar approach. We're taking data from our customers, turbo machinery and Station Edge, bringing it back. And with a fleet manager, which is an option through Solar, we monitor and bring back and say, hey, you know what? Things changed in your fuel. We don't like what we're seeing. Or you're operating differently. Did you know your operations is doing X, Y, Z? Or, hey, we think we can optimize your operations by doing X, Y, Z. And I realize I'm not giving you guys specific examples. And it's really because we have a bunch of webinars on solarturbines.com. I won't bore you with the details if this is something you're interested in. We have plenty of people that love to talk about it. But I'm going to save you all the details tonight, promise. So like I said, why does that data matter? It matters for things like pipeline optimization. It matters for things like hydraulics, your compressor performance, all things that help you with your reliability of your product, as well as your performance at site and your total asset altogether. So if you're interested more in the pipeline optimization portion of it, like I said, there's a great webinar on solarturbines.com. We can talk more after this, but I'm going to save everyone the details since we did start a few minutes late. So anyway, decades of unmatched expertise. So Solar has created this baseline, right? Through our product definition, our standardization of all these individual components. We know baseline how this product should be. Through the Insight platform, we're able to take that data and really take a deeper dive into how you're running your machine, how the modularization and this standard set of components that we provided are optimizing on the back end, right? And we're able to tweak, we're able to give feedback, and we're able to really help optimize with that frame of reference, which is our standard overall product. So if anyone has any questions, please let me know. But like I said, through standardization gives you modularization, these parts and components on a modularized basis. And through that, we get to optimize and refine our products.
You make your own fin fans?
We do not.
No. Okay. But I was just wondering,
Any questions?
is that part of the package? You go through it, you don't make your own, but you also supply it as your part of your package, right? Okay.
Yes, this is Randy Barnett. I'm with Johnson Controls. Can you hear me?
Yes, we can.
I've got a couple of questions. Early in your presentation, you had mentioned that your construction services and turbofab team are based here in Houston, and they're engaged with projects all around the world. Is that correct?
That's correct. Yes.
Okay. And then a few slides later, you talked about your open ground modular
Yep.
system,
Mhm.
and then also some of your modular building enclosures. So in the drawing or the slide that had the open ground modular system, it appeared as though you had some fan coolers there, and I assume your system was located underneath the fan coolers. Is that correct?
Are you talking about our loop oil coolers out in the balance plant field?
Yeah, I don't know, maybe if you can go back to that particular slide. It was the slide that,
Are you talking about the process coolers out
well,
here?
keep going, one more.
Okay.
Nope, keep going the other way.
Oh.
When you first talked about the, keep going. I think it's earlier.
Okay.
Keep going. Right there.
Mhm.
On that slide, the slide on the left,
Mhm.
are those fan coolers I'm looking at, or is that something else?
Yeah, these are our process gas coolers. Yes.
So when you say process, so you actually have gas going through those.
We have gas that is cooled by the fin fans. Yes.
Okay, so it is a fin fan, but instead of
He's talking about, I
water
think he's
going through
talking
the
about the
tubes.
ones, the small ones, not the big ones.
Are you talking
Yeah.
about this one or this one?
Yeah, that one, the big ones.
Yeah, these are our process
Oh.
gas coolers. Yes, that's correct. Then my answer.
Okay, so
This
so
is
in
our
that
loop
case,
oil cooler.
you're using fan coolers, and you've got gas in the tubes, and of course you're using air, ambient air, to go across it, correct?
As a cooling mechanism, yes.
Okay. Do you guys make those yourselves?
No, we do not.
Okay. And then and I guess the only difference between that and the modular is the modular, basically you're protecting the equipment from the outdoor environment. So everything's mounted indoors. Now, with any of that equipment, do you include as part of your package any type of refrigeration equipment to with maybe process heat exchangers to cool down gas before it goes through your process?
No, we do not. We just use the, oh no. Oh, boy.
Well, Randy, I could probably help
the
answer your
inevitable
question.
blue screen. I apologize, guys.
No, it's okay. Go ahead, Lauren.
No.
I was gonna say, for the refrigeration process, if that's a nitrogen compressor, you just circulate the nitrogen right through the heat exchanger process, and that's the refrigeration.
Okay, so what if it's not a nitrogen system?
Well, there's others. There's helium, there's hydrogen, there's ammonia. So, mixed refrigerant, it could be any refrigerant to provide you that cryogenic process.
Yeah, I mean, we've been engaged with some projects in other part of the world where we're providing an actual refrigeration system coupled with a gas to water heat exchanger
Yeah.
that is pre-treating the gas before it gets to the process. So
Yeah,
I guess where I was heading with solar turbines, and actually we work with solar turbines on some other projects around the world. So
right.
I will follow up as a sidebar with your presenter. But
Yeah, definitely. The heat exchangers, they're a little bit unique when it comes to these types of processes.
yeah,
but,
now in the presentation, there was another slide where there was reference to 5,000 plus ton water load capacity. What did you really mean by that statement?
So we have a capacity for load out of 5,000 short tons on our load out deck at TurboFab.
Okay, but you put it in terms of water.
Sorry, I don't have the slide in front of me.
Okay, I guess where I was getting to was
I
you
can
were
tell you
basing
the
it on,
intent of that was either for the capacity or the weight of the single lift module in the yellow structure that I showed.
okay,
or
so you were
the-
talking tons in terms of weight, not in terms of refrigeration capacity or process capacity.
No, it was in terms of weight, yes.
Okay, I got you. I misinterpreted. Okay, that was all my questions.
Okay.
Thanks.
yeah, she was talking about the weight of that lifting shackle. Mhm.
Anybody else? We're still rebooting over here.
Oh, that's okay. Hi, Ellen.
Hi, Lauren. What about any of our students in here?
Oh, yeah, how many students are there?
Small handful, big handful.
And they get extra credit tonight. Oh, there's Norm. There's Norm right there. How you doing, Norm? All right. Oh, that was excellent. Yeah.
I hope so.
Anybody else have any questions? I'd like to thank our speaker. Normally, we have a little thing to give you, but we'll have to mail it because stupid me ran off without bringing it. We'll have a wonderful gas turbine
I love it.
paperweight for you. To add to your
Perfect.
collection.
Well,
Yeah, it's a nice crystal. yeah.
yes, well, stupid me forgot my
Turbine.
computer charger. Apparently it can't handle an hour. Who would have thought?
Life goes on. And I believe that probably concludes things for our presentation. Now that you got a computer back up. ready to rock and roll.
Yes. All right, well. if
Thank
anyone-
you all for coming by and visiting the university and for listening to the presentation.
Hey, great job, everybody.
I try.
Wonderful,
I
wonderful.
had some help, but I try.
Teamwork makes the dream
I don't
work.
take credit for a lot of things, but most of the stuff you see, I will take credit for.
Yeah,
At least
that
I
was
knew
nice.
what to order. I don't know how to run all of it, but I knew what to order.
Bigger colleges.
We try.
Bye, everybody.
Try to stretch a dollar.
Good night.
Bye, Lauren.
All right, bye-bye.
Yeah,
Sorry, I'm gonna go to a road shop then tomorrow, next couple of days, I guess.
Seems to work out.
Just our 8 PM, whatever it is now, she's, it's gonna be the town hall meeting.